Welcome back to the explainer that is absolutely going to change everything you thought you knew about taking your exams. Seriously, today we are stepping right into the matrix of Cambridge computer science. Whether you are currently tackling syllabus code 0417, 0478, 2210, or you're pushing ahead into 9618, I need you to understand one fundamental truth right now before we do anything else. Are you ready? There is no test paper. There are only predictable patterns. You see, way too many students walk into that exam hall feeling like they are about to face a completely random assortment of impossible questions. They are stressed, they are sweating, and they're just hoping the topics they studied happen to show up. But what if I told you that the examiners are actually using a very specific underlying code? It's true. And once you learn to see this code, once you truly decode the exam reality, those intimidating past papers completely transform. They stop being scary and start becoming a straightforward puzzle where you already hold every single one of the pieces. Today, we are taking dense topics, specifically looking at binary and denary number systems, and we are going to run a highly focused procedural coaching session. This isn't just about memorizing facts. This is going to fundamentally rewire how you approach every single question from here on out. Okay, let's dive right into our roadmap for this session. First up is the challenge, where we identify where things go wrong. Then we hit the strategy reveal, followed by the transformation. After that, we'll get hands-on with an interactive workshop, and finally, we'll wrap up with the final system to lock in your revision. Section 1, the challenge. Let's talk about a little something called the isolated fact trap. To really understand what goes wrong in the exam room, we need to look at two archetypal students. Let's call them Alex and Sam. Now, when asked why an automated factory robot uses binary, Alex completely overloads the answer with raw facts but provides absolutely no analysis. Alex wrote that binary is base 2, it uses zeros and ones, and computers only understand binary because of transistors. Now, ask yourself, is that true? Yes, functionally it's true, but does it answer the specific scenario about the factory robot? Absolutely not. It is incredibly generic, and honestly, it gains minimal marks because it's just memorized terminology floating in total isolation. Then we have Sam. Sam rushed the question and completely missed the core requirements. Sam wrote that the robot uses ones and zeros for its sensors. That's it. It's totally rushed. It completely misses the crucial explanation of how the analog data from the sensor actually has to be converted into digital binary data for the microprocessor to even understand it. Here's the reality check. In Cambridge computer science exams, you do not reach the highest marks by writing short labels alone. Memorizing terms in isolation, without anchoring them to the digital scenario provided in the prompt, is an immediate glaring red flag to the examiner. It screams that you know the vocabulary, but you don't actually know how the technology works in the real world. And this brings us perfectly to the classic exam pitfalls that examiners see literally thousands of times every single year. The most common errors usually stem from really vague wording or missing critical process steps. Think about it like a recipe. You can't just jump from the input directly to the output without explaining the logic processing that happens in between. Another massive trap, naming a device or a method without actually explaining how it works or why it provides an advantage in that specific situation. But you know what the absolute biggest pitfall is? Confusing nearby concepts. The theoretical foundations of computer science heavily depend on your ability to distinguish between things that sound very similar. If you confuse memory with storage, or a protocol with a service, or a compiler with an interpreter, or even binary with denary, you are going to lose the mark. For sure. You absolutely must train yourself to write clear comparisons, not just single-topic explanations. Section 2. The strategy reveal. It is time to shift our mindset. We're officially moving from passive memorization to active decoding. I need you to stop thinking like a student trying to perfectly remember a textbook and start thinking like an engineer trying to solve a real digital problem. Top students, the ones who consistently score at the very top, they structure their responses using a highly disciplined path. We call this the Peel framework, perfectly adapted for computer science. Here is how it works. Step 1, point. You have to identify the exact requirement of the task. Are they asking for a hardware selection, some binary manipulation, or logical reasoning? Step 2, evidence. Classify the relevant data or process that proves your point. Step 3, explanation. This is where you explain how the process works in a clear, logical sequence that another learner could easily follow. And finally, step 4, link. You have to connect that technical explanation right back to the context. You must check whether the question wants causes, effects, advantages, or design decisions, and you must tie your answer directly back to the scenario you were given. All right, let's put this to the test. I want you to evaluate two different answers for that automated factory robot scenario. I'm putting 30 seconds on the clock right now. Which one of these successfully follows the Peel framework to secure full marks? Take a close look at the structure. While you're figuring that out, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, time is up. Let's see how you did. If you selected the answer that clearly stated the point about the microprocessor, evidenced it with the need for digital data, thoroughly explained the analog to digital conversion sequence, and then linked it directly back to the robot's temperature sensors, well, congratulations, you are starting to see the matrix.
Section 3. The transformation. Knowing the framework is great, but applying it under pressure is where the magic happens.
We are going to take a deeply flawed answer and rewrite it live right now, moving it from a generic definition covered in red pen to an examiner-pleasing masterpiece with a big green checkmark. So our original, flawed answer simply states that binary is ones and zeros used by computers to process data. As we discussed, this is generic, vague, and frankly worth 0 marks. But when we apply our blueprint, it brilliantly illustrates exactly what examiners are desperately looking for. Watch this transformation. First, we identify the microprocessor in the industrial control system. Next, we explain the specific sequence. We state that the continuous physical data coming from the robot's temperature sensor must be converted into binary using an analog to digital converter, or ADC. Finally, we provide the link to the consequence. This must happen before the logic processing can actually determine if the machine is overheating. Do you see the difference there? We didn't just give a dictionary definition of binary. We showed exactly how it functions inside a specific industrial control system. This approach literally forces the examiner to award you full marks because you have demonstrated applied understanding, not just surface-level recognition.
This brings us to what might be the single most crucial rule of Cambridge computer science exams. I call it the context anchor. Listen carefully. Examiner-style performance depends entirely on absolute specificity. Generic responses almost never gain full marks. If the context in your exam question is about a school, an office, a local area network, an embedded system, a website, or a security incident, your answer absolutely must stay inside that context. The context is your anchor. If you unmoor from it and just float away into general theory, your marks are going to float away right along with you. It really is that simple. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. The interactive workshop. You know the theory, you understand the blueprint, and you've seen the transformation. Now it's time to test your pattern recognition skills. I am going to throw 3 rapid-fire exam challenges at you. Challenge 1 is the data scan. Imagine you have a 60-second visual countdown timer ticking away. You are looking at an 8-bit data packet in binary. Your job is to extract the core trend from this data source and convert it to a Denary context. You need to diagnose the demand correctly. Think about the column headers for an 8-bit binary number. Going from left to right, we have 128, 64, 32, 16, 8, 4, 2, and 1. Now, where are the ones placed in this specific packet? We have a 1 sitting under the 64, we have another 1 under the 16, a 1 under the 4, and a 1 under the 2. Let's add those up together. 64 plus 16 gives us 80. Add the 4, that's 84. Add the 2, and we get 86. The Denary value is 86. But wait, remember the context anchor we just talked about. If this data packet represents an ASCII character, or maybe a pixel color value in a digital media processing scenario, you have to state that 84 represents that specific piece of data. You can't just do the math. You have to apply the math directly to the digital scenario they gave you. Awesome. Let's move to challenge 2, find the flaw. For this one, I want you to act as the examiner. I am presenting you with a flawed paragraph that is attempting to explain network security within a school context. 3 of the sentences in this paragraph are perfectly accurate and properly context anchored. But one sentence is completely off topic and is guaranteed to lose marks. Can you spot it? Read through the points carefully. Have you found the flaw yet? It's the point claiming that hexadecimal is used because it takes up less storage space on the hard drive than binary. Wow, that is a classic wrong turn, and it's a trap so many people fall into. Hexadecimal does absolutely not take up less physical storage space in computer memory. The computer still processes and stores every single piece of data in binary. Hexadecimal is used simply because it is shorter and much easier for humans to read, which drastically reduces transcription errors for network administrators when they are configuring systems. The student who wrote this confused human readability with physical machine storage. And honestly, that kind of mix-up is exactly how you lose an entire grade boundary. Ready for challenge 3? This is speed writing. You have exactly 30 seconds of mental speed writing right now. I want you to draft one perfect Peel paragraph explaining exactly why hexadecimal is used over binary for MAC addresses, specifically in the context of a network administrator's office. Remember the sequence? Point, evidence, explanation, link. Your mind should be racing through this. Point. Hex is way easier for humans to manage. Evidence, it uses 16 characters instead of just 2, effectively compressing the visual length of the data. Explanation, a 48-bit MAC address is incredibly long and unwieldy in binary, making it very hard to type out manually. Link. Therefore, the network administrator in the office will make significantly fewer transcription errors when setting up or configuring the school's routers. Boom, that is absolute specificity. That is exactly the examiner-style performance that guarantees top marks.
Section 5. The final system. You've survived the workshop, which is fantastic, but exam day is a marathon, not a sprint.
To ensure you maintain this level of performance, you need a reliable revision system that guarantees real-world exam adaptability. Enter the 3-pass revision cycle. This is a layered studying style that completely stops students from just writing down everything they know without any direction. It moves you from mere recognition to true adaptable application. Pass 1 is all about securing definitions and contrasts. Don't just define binary, contrast it directly with Denary. Contrast RAM with ROM. Contrast fishing with farming. You need to know the differences, not just the definitions. Pass 2 requires you to rehearse worked explanations. Literally write out the exact step-by-step sequence of how an ADC works or how a laser printer puts toner on a page. Pass 3 is where you practice exam adaptability. This is the fun part. Take a past paper question about a hospital database and cross it out. Change the scenario to a retail inventory system. Now, can you still answer it? Can you mix similar terms and logically justify your choices? If you can adapt the scenario yourself, you have truly mastered the code.
Finally, I want to leave you with an incredibly reliable memory structure. If you are ever feeling stuck or overwhelmed during your revision, just fall back on these 4 memory prompts. Ask yourself, what is it? How does it work? Where is it used? And why is it better or worse than an alternative? Let's test this out against binary. What is it? It's a base 2 number system. How does it work? It represents the simple on and off states of physical transistors. Where is it used? In microprocessor logic, embedded systems, and hardware registers. Why is it better or worse? Well, it is absolutely essential for machine logic, but it's terrible for human readability compared to something like hexadecimal. If you can confidently answer these 4 prompts out loud for literally any topic in the Cambridge syllabus, you are completely, undeniably exam ready. If you struggle to answer them, that is your cue to go back and rebuild that specific topic from a worked example. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. The difference between a B and an A star isn't just raw intelligence, it is strategy. It's about decoding those command words, flawlessly applying the Peel framework, and managing your time effectively. Every single concept has a pattern, and every question has an underlying architecture just waiting to be decoded by you. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So I leave you with this final provocative thought. When you sit down in that exam hall and you turn over that paper for the very first time, what are you going to do? Are you just going to read the paper like everyone else hoping for the best? Or are you going to see the underlying code? Will you immediately spot the context anchor, map out the required process steps, and effortlessly dodge the contrast traps waiting for the unprepared? You now have the ultimate blueprint in your hands. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. Keep decoding, and I'll catch you in the next one.